So now in this class, let me discuss exercise 4.6, right? Okay. 4.6 to examine the consistency and inconsistency. Examining the consistency of the given system of equations. Okay. You consider the following equation: a1x plus b1y plus c1z is equal to d1. First equation. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d2. Consider the following system of equations. Okay, you can go for a simpler one. Okay, shall we go for the simpler one first? We'll go for the simpler one. a1x plus b1y is equal to c1. a2x plus b2y is equal to c2. So consider this system of equations. Now I'm going to introduce a matrix A, and let your matrix A be the matrix consisting of the coefficients of x and y from the above equations. Okay, I'm going to introduce a matrix X A, and this matrix A consists of what? The coefficients of x and y of this given equations. So here a1, b1, a2 and b2 in this order. Is it okay? Where the first column contains the coefficients of x from the given equations, the second column consists of the coefficients of y from the two equations. Let your matrix X be your column matrix containing the variables x and y, and let C be the matrix consisting of the constant terms C1 and C2 in column matrix, as column matrix. Is it okay? Or we can take this as B. Let B be the matrix. It's a column matrix consisting of the constant terms from the given equations. Then, if we consider this case, then we can rewrite this system of equations in this form. Ax is equal to b. Okay? If from these equations, if we consider this, now if we take these conditions, then the entire system of equations can be represented in this form. X equal to b, where A is your this matrix, X is this matrix, B is this matrix. You solve this, you get this back. Okay, ito solve ko ito papas pa po ni system. To inaka system of equations ke inaka likhiwo pare considering these matrices. Is it okay? Are ito lang advantage ke ase? We can find out x. We can find out the variables by writing x equals to A inverse. So this method of solving this system of equations, this method of solving this system of equations is known as your matrix method. So question can be asked, solve the given system of equations by matrix method. This is how you have to proceed. Okay? Yeah. Now, similarly for the system of equations, if we consider the system of equations in this way, a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. And then you take your matrix A to be A1, B1, C1, A2, B2, C2, A3, B3 and C3. where your matrix A consists of the coefficients of x, y, z from the given system of equations arranged in this order. Huh? Your matrix X, let your matrix X be a column matrix consisting the variables x, y, z, and B be another column matrix consisting of the constant terms, okay, from the given system of equation. In that case, if you consider these situations, then your given system of equations can be written as AX is equal to B. Tadi ba X to kinakapisari mo? X means these variables, right? How can you find out the solution? By writing X equals to A inverse. So this is known as your matrix method. We can find out A inverse only if A is non-singular, right? Only if A is non-singular, then we can find out A inverse using the formula A inverse is equal to adjoint of A divided by determinant of A. In the previous classes we have studied, not yesterday. A inverse means adjoint of A divided by determinant of A, but only if A inverse is, or if only if A inverse exists. That means only if A is non-singular, then we can do it by matrix method. Is it okay? In case if A inverse does not exist, that means your matrix A is singular. That means determinant of A is 0. If your determinant of your matrix A is 0, then A is singular. In that case, A inverse does not exist. In that case, there is no solution for the given system of equations. In such a situation, the given system of equations is said to be inconsistent. So examining the consistency means you have to express the given equations in this form. Know what is your matrix A. Check whether the inverse of this matrix A exists or not. If the determinant of this matrix A is 0, then in that case your matrix A is singular, right? In that case it is singular. That means A inverse does not exist. So no solution can be obtained. Then your given system of equations is inconsistent. First case. Okay? But if A inverse exists, that means if your determinant of A is non-zero, then your matrix A is non-singular, then your A inverse exists, then your given system of equations has solution, right? So, consistent. Are you getting that? Let me explain to you, okay? In the simplest way, let me explain it to you again. You want to find out the solutions for this given system of equations, then what you have to do, you have to first form matrix A, form matrix Y, form matrix B. Okay. Now, case 1. If determinant of your matrix A is not 0, in that case, your matrix A is non-singular. So, A inverse exists. That means the given system of equations is consistent. And hence we can obtain the solution using the matrix method. Done. Over. Case 1. Let's go for case 2. In case 2 means what happens if determinant of A is 0? Now, if your determinant of A is 0, then what happens? A is singular. So A inverse does not exist. Now we have two situations over here. In case 2, we have two more situations. If determinant of A is 0, now, if determinant of A is 0, and if adjoint of A into your matrix B is not 0, determinant of A to 0 will be adjoint of A times your matrix B to 0 no hoy. In that case, the given system is inconsistent. Over. Now, second one, if determinant of A is 0, second case last na, if determinant of A is 0, but adjoint of A times B is also 0, type is 0, type is 0, then in that case, your given system of equations can be consistent or inconsistent, depending on whether these equations have infinite solution or no solution. Are you getting me? Are you getting infinite solution? Will be consistent. Consistent was a solution. So consistent. So whenever a system of equations has solution, then it is consistent. Whenever a given system of equations has no solution, then it is inconsistent. Okay. So this part is done. In the second case, if determinant of A is 0, then we have two conditions. If determinant of A is 0, but adjoint of A into B is not 0, then the given equations is inconsistent. So that's the end of the story. Second case, if determinant of A is 0 and also adjoint of A times B is 0, then these given equations can be consistent or inconsistent, depending on, here also A inverse 2 does not exist, okay? Now, so in this situation, it can be consistent or inconsistent depending on what kind of solution they have. That means they can have either infinitely many solution or no solution. Infinitely many solutions are consistent. No solution could be inconsistent. Are you getting that? Are you getting that? So that's the introduction here. So from question number 1 to 6, you are only asked to check the consistency. Whether is it this? Itu wasena? Itu wasena, itu wasena. Itu check kori. Is it okay? Or itu telekivo? Then the given system is consistent or inconsistent depending on whether the given equations, the given system of equations has infinite solution or no solution. I want you to write this condition. Okay, I want you to write this condition. Let me pause the video. So exercise 4.6, the first question, examine the consistency. So here though you need not solve, you want to check whether the given system of equations is consistent or inconsistent. So number 1, given system of equations are x plus 2y is equal to 2, 2x plus 3y is equal to 3. And then I want to do Roman 5. 3x minus y minus 2z is equal to 2. 2y minus z is equal to minus 1. 3x minus 5y is equal to 3. I think it's correct now. So let's go for number 1, the first one. Given system of equations are x plus 2y is equal to 2, 2x plus 3y is equal to 3. Let A be your matrix. What? A means a matrix containing the coefficients of x and y from the given equations, but the arrangement should be 1, 2, 2, 3. The first column means coefficients of x from the given equations. Second column means coefficients of y from the given equations. Let x be the column matrix containing the variables x and y, and B be another column matrix containing the constant terms 2 and 3. So let's see what is the determinant of A. Determinant of A means determinant of 1, 2, 2, 3. 1 times 3 is 3, minus 2 times 2 is 4, so that is minus 1, which is not 0. So determinant of A is non-zero, means your matrix A is non-singular. That means A inverse, therefore A inverse exists, and hence the given system is consistent. Correct? Only if this is 0, we have 2 cases more, okay? Any problem? Okay. Only if this is 0, then we have 2 cases. Otherwise, if this is non-zero, then done. Okay. Now, for this case, solution, given system of equations are 3x minus y minus 2z is equal to 2. I need not repeat writing it again, no? Let me just make this as your solution. Question number 5 solution. So I can write here, given equations are, means given system of equations are. So let A be the matrix containing the coefficients of x, y, and z from the above equations. 3 minus 1 minus 2. In the second equation, there is no term containing x, so its coefficient will be 0, right? 0, 2, minus 1, and then 3 minus 5, 0. Let x be the matrix containing the variables x, y, z, column matrix. X is a column matrix, and let B be another column matrix containing the constant terms from the given equations. Let's check what is the determinant of A. Determinant of A means determinant of 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0, right? Let us expand along R1. So 3 and then R1, yeah. 2 times 0 is 0, minus 5 times minus 1 is 5, right? Minus of the next element, minus 1, so plus 1. And then we cross multiply the remaining elements. 0 minus 3 into minus 1 minus 3, so plus 3. And then we have minus 2. 0 into 5, 0, minus 3 2 times is 6. So minus 15 plus 3 plus 12. Unluckily, your determinant is 0. It means A is singular. Therefore, A inverse does not exist. But we cannot say whether it is consistent or inconsistent. We need to find out the adjoint of A and multiply with B. Okay? And then the product of adjoint of A and B, if the product is non-zero, if this is 0 and product of adjoint of A and B is non-zero, then no solution can be obtained. So this will be inconsistent. But if determinant of A is 0 and adjoint of A times B is also 0, then the given equation can be inconsistent or consistent depending on what kind of solution, whether infinite solution or no solution the given equation says, right? So should we take time to find out adjoint of A? So let's find out adjoint of A. In order to find out adjoint of A, you have to find out the cofactor of all the elements of A. So the cofactor of the first element, A11, cofactor of 3, denoted by A11, will be 1 plus 1, 2, so positive, right? And then
0 plus 5. 5. Minus.
0 minus 5, right? No? Okay. Minus 1 to the power 1 plus 1. That is minus 1 to the power 2, which is positive. And neglecting the rows and columns where this element belongs, we write the determinant, right, of the remaining elements. 2, 0, 0, minus 5. So that is minus 5, right? A12, minus 1 to the power 1 plus 2, 3, so negative. And then we write the minor of this element. Minor of this element is 0 into 0, 0, 0. Minus of 3 into minus 1, minus 3, so plus 3. So that is minus 3, right? A12, what about A12? A12 means minus 1 to the power 1 plus, I'm sorry, A13 now. Minus 1 to the power 1 plus 3 is 4, so positive. And then we write the minor of this element. 0 into minus 5. 0 minus 3 2 times is 6, so that is minus 6. What about A21? A21 minus 1 to the power 2 plus 1, 3, so negative. And then we write the minor of this element. Minor of this element means 0 minus 10. 0 minus 10, so that will be plus 10. A23 will be A23. A22 will be positive, right? Minus 1 to the power 2 plus 2, 4, so positive. And then the minor of this element, 0 minus of minus 6. 0 plus 6, right? And A23 will be negative. Minor of this element, minus 1. Minor of this element, 15 plus 3. 15 plus 3, that is minus 18. Minor of this element, right? So, itu jabo dong. 3 into minus 5, minus 15, right? Minus 15. Minus 15. And then minus of 3 into minus 1 plus 3. That is minus 12. Minus into minus plus 12. A21, A22, A23. A31, minor of 8, minor of this element. A31, 3 plus 1, 4, so positive. And minor of this element means 1 plus 4. 1 plus 4, that is 5. A32 will be negative of minor of this element. Minus 3, minus 3, minus 0. Minus 3, minus 0, that is plus 3. And what about A33? A33, minor of this element will be 3 2s are 6. 6. Yeah, 0. Or 6 minus 0. That is 6. Therefore, adjoint of A will be the transpose of the cofactor of the elements of this matrix, right? Minus 5, minus 3, minus 6, 10, 6, 12, 5, 3, and 6. Now, therefore, your adjoint of A, therefore, adjoint of A will now be, transpose of this matrix will be, first row becomes the first column, minus 5, minus 3, minus 6. Second row becomes the second column, 10, 6, 12. 10, 6, 12. And then 5, 3, 6. Third row, third column, 5, 3, 6. Now we have to find out the product of adjoint of A and your matrix B, right? That is your matrix. Now, let us find out the adjoint of A times your matrix B. Adjoint of A is minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6, and to your matrix B, 2, minus 1, 3. Right? First row will multiply first column. First row will multiply first column. Gimana mo? Minus 10, minus 10, minus 10, plus 15. Minus 10, minus 10, plus 15. Right? Next to second row with second column. Minus 6, plus 9. Nah? Minus 6, plus 9. And then minus 12, plus 18. So this is equal to what? Minus 5, minus 3, 6, which is not equal to 0. So determinant of A is 0, right? But adjoint of A into B is not 0. Huh? Therefore, the given system of equations is inconsistent. If this was also 0, then it could have been consistent or inconsistent, depending on whether your equation says what? A solution or no solution. Okay. So that's all. That is how you check the consistency. Okay. Let's see, you can try one.